Okay, hello. Welcome back to our series on graphing systems of linear inequalities. The previous video, we learned how to graph one single linear inequality. In this one, we're going to learn how to graph a system of them. So let's first start by graphing one of them. All right, so I'm going to write out the first one, so x minus 2y. Now remember, the method is you would write it as an equal sign and then graph the line. So let's pull up a graph and start by graphing using, well, the intercept method because this is in general form. So let's let x equal 0. Now when x equals 0, that term goes away, and you can solve for y. Solving for y, you can see y will be negative 1. And then when we let y equal 0, that term goes away. Solving for x, you'll see that x equals 2. And we'll plot those 2 points. So 0, negative 1, that's right there, and 2, 0, be right there. So let's connect the dots to make the line. Now in order to figure out what side to shade, we're going to do our test points. For this one, I'll test, again, you should probably pick the origin, but we'll pick this point. So how about 1, 2? So let's test that point. So over here, test point. All right, so now you're testing this on the original inequality, so that would be x minus 2y less than or equal to 2. So let's plug in our points. So we have x is 1, so that would be 1 minus 2 times now y, which is 2. And so that's 1 minus 4. That's negative 3. And so is negative 3 less than or equal to 2? And it is. So that checks out, meaning that we graph, or we shade the side containing that test point. So we'll shade up here. And we successfully graphed this inequality. So what I'm going to do is I'm going to move this over, because then we're going to graph the second inequality. So let's just move this over here. Okay. So now let's graph 3x plus 2y equals 6. Now this equation is also in general form, so we can use the intercept method. So let's let x equal 0. And if you let x equal 0, then we just have to solve for y. You'll see that y equals 3. And then when we let y equal 0, 3, there we go. And when we let y equal 0, that term goes away. We got to solve for x. 3x equals 6. You can see that x equals 2. And now we have our two intercepts. So we got 0, 3, which is up here, and then 2, 0. And then we'll connect these two dots. The last step would be to figure out what side to shade. So we're going to do a test point. Let's see. Let's just do the origin with this one. So let's test the origin. Oops. Okay, now remember that we are plugging it back into the original inequality. So that would be 3x plus 2y greater than or equal to 6. So now if x is 0 and then y is 0, is that hold true? Is that less or greater than or equal to 6? Well, these are both 0. So is 0 greater than or equal to 6? And it's not. So don't shade the side containing the origin because that point did not work. So let's shade the opposite side. So we would shade away from the origin. All right, so let's go ahead and shade this. Okay, now with a system of equations, which we did in the previous series, you found that a solution to a system would be a coordinate point that worked for both equations. It's the same idea for a system of linear inequalities. Since the solution would be the shaded region, if you wanted to know what's a solution to both linear inequalities, we're looking for what shaded region appears in both. In other words, where do they overlap? So what I'm going to do is I'm going to take this graph right here, and I'm going to lay it on top of this one, and then we'll see where they overlap. Now that we've placed the graphs on top of each other, you can clearly see where they overlap. I chose to shade each region in different directions, so this lines were going this way, and then the other shaded regions lines were going the opposite direction. So you can see when they overlap, they make a completely different shaded region. Now the answer would then just be shade the region, because this is where they overlap, meaning that any point in this region is going to work. So let's take an example. How about like 2, 3? Let's see if that works for both inequalities. So we've got x minus 2y less than or equal to 2. So let's plug in 2, 3. So we get 2 minus 2 times 3. Is that less than or equal to 2? So that's 2 minus 6. And that's negative 4. So is this true? Yes, it is. And so that point works. Let's try it with the other inequality. So it was 3x plus 2y greater than or equal to 6. So that's 3 times 2 plus 2 times 3. Is that true? Is that greater than or equal to 6? Well, this is a 6, so is that. So that's 12 greater than or equal to 6, and that is also true. So that means that this point works for both. Now what you can also do is go back and erase the shaded regions that don't work. Right? It isn't as nice looking. Okay, so that's why we would darken in the area that works. But there you go. So let me just erase a little bit more. Okay, but I think you get the idea. So here's my shaded region. All right, so let's try another example. Okay, on to our next example. We have x plus y less than or equal to 4, 2x minus y greater than or equal to negative 1, and then we have these additional pieces down here, x greater than or equal to 0, and y greater than or equal to 0. What this is doing is it's restricting your shaded region to the first quadrant, because when x is greater than or equal to 0, it means you are to the right of the y-axis, and when y is greater than or equal to 0, it means you are above the x-axis. So you can see how these two arrows, the shaded region, would overlap in here. Okay, so I'm going to leave these arrows here for now. Actually, you know what? Let's erase them. I just don't want them to get in the way of our lines. So let's move on to the first line. We have x plus y equals 4. Remember to change it to an equation. Okay, so this is in general form. Should be pretty simple to graph. When x is 0, it means you don't have that term, and you can see that y would have to be 4. And when y is 0, you can see that x would have to be 4. Okay, so these are our two intercepts, so let's go ahead and plot those. So we got 0, 4, puts us right here, and 4, 0. Okay, so let's connect the dots to make the line. Next, we just have to figure out what side to shade. So let's go ahead and pick the origin as our test point. So our test point would be 0, 0. So with the original inequality, remember the original inequality is x plus y less than or equal to 4, will it work? So if x is 0, you get 0. When y is 0, 0, and then less than or equal to 4, so 0 less than or equal to 4. And it is. So let's shade towards the origin. Now instead of actually doing something like this, which we can do, and you can leave it like this if you'd like, what I'm going to do is just use little arrows, just to remind myself, hey, when I do my shading later on, shade to this side. That way I don't have a big mess already, and I still have to graph another line. Okay, so now we've determined the shading for this one. Let's actually move this down here next to its line. Now let's go on to the next line. Now our next line is 2x minus y equals negative 1. Alright, so this also in general form. So now if you were to let x equal 0, what would y have to be? So again, if you cancel out that x, y, you can see, would have to equal 1. And then when y is 0, you won't have that term. What would x have to be? If you solve for x, it would be negative 1/2. And again, pause the video to verify this for yourself. All right, so let's plot those points. So we got 0, 1, and then negative 1/2, 0. Puts me right there. And so let's connect these dots to make the line. Okay, now which side do we have to shade? So we're going to go ahead and do our test point over here. For a test point, how about we do this point right here, 2, 0. All right, so we got 2, 0. Okay, so with the original inequality, so let me write the original inequality again, which was 2x minus y greater than or equal to negative 1. Let's go ahead and plug in our point. So we got 2 times 2, because that's x, minus y, which is 0. Is that greater than or equal to negative 1? In other words, is 4 greater than or equal to negative 1? And it is. So we're going to shade towards that point. So here's our red line, or here's our current line, and we're going to shade in that direction. Okay, now that I've figured out what sides I'm going to shade, you can kind of see from right here that these two lines, the arrows are pointing here. So this is where the overlap would be. But we do have these extra conditions, which again, right here, meant restrict yourself to the first quadrant. So yeah, right now our shaded region is in here, but we're not supposed to be down here. We only want in here. All right, so what you would do is you would just erase everything and just maybe do this if you'd like. So now you can see that every arrow is pointing to this spot. So let's go ahead and fill that in because that is our final answer. All right, so there you go.